Well, I guess we can get started a little bit. We might have a couple more people. I know a couple more people were talking about wanting to talk to you. But we can start off and then we can run questions a little bit later. Um, but welcome everyone who is here. We're meeting with Rowan today, and he is both you're a core contributor to MyST, which is like markedly structured
Structured
text.
text. Yeah.
And so it's Markdown, but way better and specifically formatted for scientific uses. And then he's also building Curvenote, which is kind of like a platform to bring that into an interface that works really well. And so I'm super excited to talk to him today about all these things he's building and see how it goes. So you can kick off, Rowan, whenever. The other note is right now we'll gather questions in chat as they go, and then he'll call for questions in a chunk during the presentation.
Yeah. And well, since there's only like 6 people here, I feel like yeah, just interrupt me if you have a question. Um, yeah. Awesome. Can you see my screen?
Yes, I can see.
Switch screens. How do I switch screens? Yeah,
Nice.
you're on this one.
Yeah.
Awesome. Cool. Okay, so as Ellie said, I'm primarily working on Curvenote, and I'm also on the steering council for MyST Markdown and one of the core developers over there. Um, the way I've sort of structured this presentation is talk about a little bit of what we're doing at Curvenote, which is building publishing infrastructure for computational research, and then sort of go into the MyST Markdown side and talk about that, because I think there's a lot of overlaps with some of the stuff in the DeSci community for archiving data in a new way. So this is my caricature of science communication today. It's like a 2-column PDF document on your phone that you can't like read. And there's data in there, but it's sideways on a table. You can't copy it out. That's a really hard problem, and it's really terrible user experience as well. And it really should be so much better. And this is in a lot of the things that I'm thinking about is there's this massive growth of data and computation in science, and the way that we are communicating science is just not keeping up to those changes at all, and there's a massive dissonance there. And really, it's that sort of static publishing medium that everybody is targeting that it doesn't meet those modern communication needs. And so that's really where Curvenote is focused, is on the communication aspects and improving how we communicate research by integrating computation and data practices in there. And I think this is one of the ways to sort of reimagine scholarly publishing. And so it's maybe a different thrust of some of the things that are being considered in the DeSci community, but certainly related to all sorts of those ideals. So what if we could explore results? So instead of having a single static figure, we can actually dive in and see all of the data. And what if we could dive into footnotes and references and see videos and just sort of keep on diving down in the scholarly commons until we get to the data sets and the data and computation behind things? And what if we could actually have the models integrated directly into our reading experiences so that we could see assumptions, change them, and have that update the way that we're writing? And what if we could press a button and spin up computational resources in the cloud to actually reproduce and visualize things like new physics that are being visualized here? And so this is running a finite volume model in the cloud, directly integrated into a reading experience. And so what this really requires is all of the computational instructions and data behind the research that is published today, so that you can dive into any figure and actually see some of the computations, the data, the code, as well as the environment behind it. And what this is really speaking to is actually improving the scientific record in such a way that we can actually stand on the shoulders of giants and sort of build upon other people's research, change it, sort of take a new idea from someone's work and move that forward. And so that's the sort of types of things that we're thinking about at Curvenote is reimagining the sort of the reading experience, really making available interactivity and computation in that reading experience, as well as publishing alongside a lot of the notebooks and data and software and code behind everything. Awesome. So there are just like a ton of different pieces to this. The way that I've structured this presentation is talking a little bit about the consume side first and sort of changing that reading experience, and then talking more about the authoring experience. And where Curvenote is fitting in is trying to smooth all of this together, giving new journals and existing journals ways to change their publishing experience, as well as the peer review and submission process along the way. And then there's the other side of just everyday scientific researchers who can change their authoring experiences with open source tools. And that's that MyST Markdown project that Ellie was talking about as well. So maybe, let's see. Cool. Okay. So these are some of the journals that we're working with. So very traditional societies. So we're not sort of disrupting things there. And I'm going to show some examples from AGU and American Geophysical Union. That is earth scientists, space scientists who it's about there's like 20,000 people who show up in San Francisco every year for their conference, and they publish in like 20 or 30 different journals. And so we're working with them to upgrade and allow these sort of new types of submissions. And so I'll highlight a little bit of the work from that community to give you a sense of what's going on there. And so this is the sort of journal that we've built for them so far. And so it's a very traditional landing experience and feels like a journal. It's nicer than what's out there today. So like really paying attention to design but really pulling through all of the existing metadata like ORCID IDs and licenses and all sorts of stuff there. And then thinking through towards some of these reading experiences and being able to actually hover over something. And when we think about open science, we should be able to, instead of having a link at the bottom of a references section, we should be able to dive into a section, see the computation behind it, get all the way to the data sets that we need to download. And that should be a smooth reading experience, not just across a single paper, but across the entire scholarly infrastructure. And so that's really something that we're trying to pull through in our user experience here. And then just little things like being able to see abbreviations. And this is like you hover over SFBF and you actually can tell what it means. And there are just so many abbreviations in the scientific literature that it is really helpful in a reading experience to actually be able to know what that means. And that's possible when you have HTML with abbreviations and titles and things like that. And then again, figures, being able to hover over any sort of figure reference, see that, but not only the figure, but also the code that has created that figure as well. And so thinking about these as sort of very linked, like linked documents all the way through to the notebooks, computation, and data. And so these sort of deep dive links, links out to data sets, abbreviations, and then just like very table stakes things that almost no one does in the scientific literature or scientific publishing space today, like being able to copy code or dark mode or actually reading on your phone. Like this is where we're starting, is 2-column PDFs that you can't even really read in a coffee shop. Awesome. So moving on from there, this is something that a lot of the authors that we're working with at AGU, they have just a ton of different notebooks behind them. So this data set was, or this example, they were reproducing about 7 or 8 models from the literature, and that's a hugely valuable resource to anyone who is interested in this field of research, is you can actually do that in a consistent way, and they've provided all of the code open source. None of that is actually in the paper. That is all in these sort of supporting documents that's going through that. And this is, again, a different user interface on top of that research that really highlights all of that information. And then one of the things that they were trying to show is that each sample that they had and each model actually produced very different results, but you can't show that in a static PDF document. And as soon as we give interactivity, you can start to do very, very different things in terms of actually clicking on the results and seeing that each of these gives a different isobar curve. And then one of the other articles from this this work, we're actually able to open this and connect directly to a Jupyter interface. So this is spinning up computational resources in the cloud. You can read the paper and the source code directly. You can jump in and execute that. We're working with that society to provide those computational resources for their readers. And then in this example, you can actually change and interrogate the model in totally different ways than even the authors themselves had done. And the point of this manuscript is to explore, in this case, these are things like uplift parameters for tectonic environments and porosity for the basalt. And so this is, again, a totally different way to view the research in a much more useful way as well. And so a whole lot of different things that we're trying to do and bring this stuff to life in terms of bringing in those interactive figures, launching Jupyter, attaching all of those supporting documents and code together. And at the end of the day, you can still have your PDF documents, like that doesn't have to go away, but you can have all of this rich information that are around it. And for us, we're following all sorts of NISO standards for that. And so things like JATS and MECA are important to traditional publishing today. And so we're working to create those in a standardized way. Awesome. There's a couple other types of things that I can go into that might be interesting to talk about in terms of changing the way that we can assess research right at the start. If we're starting in computational notebooks, we can do all sorts of continuous integration like unit tests on research to assess metadata, and we can do that from the command line as well in terms of actually checking formats. And so things like corresponding authors, credit rolls, and just giving authors the ability to sort of pre-screen their work for a lot of different things. And so this is something that's, I think, quite an interesting path that we're starting to explore. And then you can submit that, create a journal, and then we have sort of inbox submission pieces behind the scenes and some peer review management and editorial management as well to actually get out all the way to those published artifacts. And so maybe I'll stop there for any sort of questions, and then we can go on to some of the authoring side, which is using that tool called MyST Markdown.
Nice. I had a quick question related to you were playing with different models in the paper itself. So I was wondering, like, how big of a data set can you actually play with? And is this like, what is the limitations of that interactivity that you have in the PDF? Like, if we need to put all of our data into cold storage, are we able to still interact with the figures the way you represented?
So I think there's certainly limits to what is possible to do. A lot of the folks in the geosciences are running things like climate models, which are on clusters and supercomputers and takes hours to months to actually run. And so that is never going to be an interactive process. Subsets of those can be explored interactively. And so that I think is where the focus can be, is really on thinking about a climate model, or we're working with some folks in microscopy as well. Maybe I'll bring up that example, where they're like recording all sorts of data for, this is like a gold nano or hollow nanosphere, hollow gold nanosphere. And so there's like a terabyte of data behind here, but you can process that data and then interact with it. And that still requires computation. And so that sort of subset is much, much more useful to someone who's actually trying to analyze this, rather than sort of a picture and a blow up that you get one picture out of. All of the data is here, you can actually do some interrogation. So it's a spectrum. I think like we're never going to be able to do full reproducibility on the fly, but you can do subsets for sure.
For sure. And then Chris, you dropped a question in chat you want to ask.
Yeah. Hey, Ron. Great to have you here. How important is just XML and HTML in your experience working with journals?
I think so. For the journals specifically, all of the ones that we're working with are archiving this in other places, and XML is what they're using. And so as soon as it gets into like a non sort of hobby journal, into something that's like even has some standards around what they're trying to do, they're going to want JATS at this stage. And so that's important from that perspective. And then for how we are working with these journals, that HTML rendering is incredibly important, because it allows these sort of next generation interactive figures, and that's sort of the main thing that we're working on.
Yeah, thanks a lot. Another question I had, how are your open source repos reflecting the version of the app that you run as a hosted solution?
Most of our work is in the open source MyST Markdown project, which gets most of the content. So this is actually not in the Curvenote GitHub organization. This is an executable books organization. So this is a community-based project that Curvenote's a part of, that is building markup languages and specs for those open source tools. And so this is like most of the infrastructure that we do, but some of our infrastructure is also closed.
So let's say we wanted to do an integration of Curvenote in the DeSci stack. What would that take?
So what an integration with MyST would look like, which is not quite the question you asked.
Well, I see that there's kind of like two possibilities. There's a side-by-side editor from the raw markdown MyST to rendered, which reminds me of Overleaf. And there's also a more what you see is what you get, like version of an editor that you've built out. So, like having the ability for authors to essentially build a Curvenote project. And because one of the things we think could be really cool is because we're building out these research objects with these IPFS drives based on UnixFS. Imagine if you have on one side these data objects and drive objects, and on the other side you have a Curvenote editor. You can start imagining interaction patterns where a user would go and just like drag and drop its data set, creating a block, or like richly linking between data artifacts. And I think that would be like a really interesting proposition.
Yep, totally. I think what we've found in working, so I haven't presented any of the writing tools that Curvenote does in this presentation, but we also do have an authoring platform that you were mentioning. What we found in that space is that people are working like there are a lot of changes that probably don't want to propagate all the way to like an immutable data store right away. And so figuring out that piece of like when you're actually committing this to the scholarly record is probably the most challenging piece. And right now that's at the publishing stage. Um, so I think that's really maybe the place to figure out what that integration would look like.
Yeah, so in that particular case, we have like, kind of like first class support for incremental publishing, right? And there's also a kind of draft private mode, and hey, we're gonna put this now on this open state data network mode, right? That final publication stage. But it's always work in progress because you can commit new versions to it. And right now we're thinking we're like kind of facing a crossroad in terms of selections, because it's clear that, just PDFs and stuff, I mean, this is not good, right? It's not good for science. It's not good for anyone. And the question is like, what kind of tools, like what kind of authoring experience should we offer in app? And I think right now Curvenote is like probably my favorite, but there's other options, right? There's, having like a tight overleaf integration. There's also having a multi-block editor, like one of these good like open source multi-block text editors.
Mhm. Yeah.
So yeah, this is a bit where we are in our thinking about that.
Yeah. Yeah, I think yeah, there's a ton of different options to explore. I think the where I was pointing towards MyST Markdown is that is a way to sort of go from that authoring experience to all the way into the structured data experience, which is, I think, an important step for anything that's doing things in the scholarly record, is that you should be able to represent the sort of semantics behind the content in a standardized way. And that is a project that's aiming to do that.
Oh, that's awesome. Yeah, I mean, yeah, we love what you guys do. Um, I think there's a huge opportunity there. How hard has it been in your experience to actually change people's habits? Because I
Very
could
hard.
see like,
Yeah.
I know you're gonna say it's hard,
Yeah.
but like, one of the things is like, how are people using your tool? Are they, let's say, getting submissions from authors in like docx or .tex, and then they're using this as the support for peer review, and then there's that two-step where they then take this input, they put it into Curvenote, and there's, or sorry, not Curvenote, MyST, and then there's a like an editorial assistant who does all this data wrangling, and you end up with like a lack of single source of truth for again. So how is the process, or are they like, oh, this is great, here's the submit button, and when you submit, you might import your document, then we render a side by side Curvenote object, and then the author can do, because these conversions are probably lossy to some degree, you can kind of like check and improve things, and now you have a single truth, single source scenario.
Yeah, much more on the tail end of what you were saying is that where we are working right now is with existing journals who are at the publish stage. A lot of the ways that people are using our web app, which is the authoring tool, is writing privately, not sharing anything, and then exporting a PDF document and submitting that to like Nature or whatever else. And so they're like doing all the structured data in Curvenote, destroy metadata, destroy all the structure,
No, how can we
export
stop
to
them
something
from
else.
doing this?
So yeah, and which is like totally the problem. And so that's where we like I started Curvenote with Steve about 4 or 5 years ago, and so we thought that it was the authoring tools that were necessary, but like you need the full, like all the way through, and so that's where over the past sort of 2.5 years we've started published or started partnering with societies and sort of changing their publishing flow all the way through. And so that I think is where we're starting to have more leverage with these societies. So I don't know, it's a journey.
Yeah,
and
yeah, and it seems it's such a difficult spot to be in because you need to operate at so many levels of the stack in order to unlock the big promised land, you know?
yeah.
Because as you say, if they go on Curvenote, then they export a PDF, then they send it to nature, you haven't solved the problem, right? Like
Yeah,
if
no,
you go,
it hasn't solved any problems other than like maybe they had a better authoring experience, but
yeah,
yeah.
yeah, but then if you go from the other road, which is, you know, like a PubPub like platform, right? We do
Mhm.
HTML publishing. Um, it's again, it's like it's just like a partial part of the puzzle, you know? And the same with data and code, you know, which is like, oh, go on Zenodo, drop your data as a zip file with 1,000 files in that, and it's going to be 2 TB, and then you know nobody can really use it, uh, because like that whole entire experience, that entire publishing stack is completely fragmented and just focused on the thing that brings publishers money, right? That's the only thing that is optimized for, is like as an APC collecting device, right? Um, yeah, and it's kind of like not clear to me. It seems like we're both, we've been like attacking this problem from different angles. Um, what does make me like really interested is that these angles, they seem they have like this baked in complementarity.
Yeah.
But yeah, I'm kind of wondering what's like your view on the future. You know, how do you think like how do we get like as a community, you know, community of people interested in really, you know, uh, uh, improving the system of science? How do we get to the promised land? You know, what would it take?
Yeah, I think, and again, I am focused on the complementary piece than some of the things in the sort of storage and archiving side. The tools that I think that scientists need better tools to author content, and so that is something that we again sort of like we switched and open sourced and brought all of our stuff into the open community, and MyST Markdown is probably going to move into the Jupyter community as a core Jupyter project in the coming months. Um, so I think that is one piece, is that like getting scientists out of Word documents and into some more of these like structured ways of working and tying it to the computation and data from the get-go. I think that creates these sort of packages that you can archive in different ways, and it's in a space where you can bring automated publishing tools, and so you could store that on a CDN or you could store that on a blockchain somewhere, but it's much easier to integrate with than a Word document that's in Dropbox or something else. And so I think this is like a part of the community that's ready to start adopting these types of tools. And so that's why I am, well, that's why we're investing our efforts in this project. And so it's
Yeah,
a step towards some of this stuff.
yeah, yeah. No, it's super valuable. Um, I'm what's on your what's like how good is the import functionality into MyST? Like if the community has like let's say a Google Doc, and they're like, this is our uh, you know, authoring or submission format. Like as a publisher on the publishing side, when I say import from Google Doc, how good is that?
Well, that one doesn't exist. The we do have LaTeX, full open source LaTeX support. Curvenote has some Word tools in our sort of tool chain, uh, which aren't public. And then yeah, we haven't focused on the Google Doc, because Google Doc can get to out to Word at least easily. And
Yeah,
so
yeah, but I mean, in the case of Word, yeah, I guess it's very similar because you can go from GDoc to DocX and
yeah,
DocX to Curve. So,
yeah.
uh, And how good were you able to get that?
It's still, so how we're using that right now is in is in sort of like a more traditional publishing workflow. And so your points about sort of breaking the single source of truth there and having these sort of manual interventions about tagging and adding metadata, that is still very much the case. And so that looks much more like a traditional publishing workflow where you hand your docx over to the publisher and then they add metadata, enhance it, get an HTML out, and then we can at least get a GitHub repo, which is the Markdown version. So we basically translate that over to Markdown, and then that becomes the source of truth that we're working with.
Yeah,
Okay.
Thanks a lot.
I think we're starting to get into some of these authoring things, and you said like this was another part of your presentation. So maybe we go through the rest of your presentation.
It's all good. I'm not worried.
Yeah, I'm like I feel like we're converging on the thing that you might be saying.
Yeah, I think I don't know. This might be helpful. Other folks might already have the background here. So MyST Markdown is a community-based project that Curvenote's quite involved in. And there's a markup language, which is sort of a superset of common markdown. And then a specification behind the scenes of sort of the abstract syntax tree that it gets transformed to, and then a whole bunch of command line interfaces and tools for HTML theming and that sort of thing that is all a part of that. So I'm sure most folks know about Markdown here. There's all sorts of different markup uh, elements of this in terms of having math or block quotes or lists or italics or sections. And then this can create documents, but there's no structured text in there. And especially when we're starting to move over towards scholarly documents, like things like figure ones and auto references and citations, those are not well supported by common markdown. And so this is where MyST is coming in, is actually adding some extra syntactic sugar on top of that. And so things like math are still in there, but we can also label math, and that's just LaTeX math with the label. We can cite things directly or just drop a DOI link in, which is pretty cool. And then having figures as well in terms of that, and then actually being able to reference them, and then other types of sections and metadata that we're collecting. And so we've put a lot of thought into how we can bridge the gap between these sort of YAML authoring representations and the forms that things like Crossref or PubMed need, which are the XML representations of these. And so there's a lot of sort of translation tools in that space. And then you get some of the stuff out that I was talking at the other side, where you're actually able to see all of that metadata, download different representations, and export to PDF documents as well. And so all of that is open source and will eventually be a Jupyter-based project, which is cool because you can do all sorts of cool stuff with Jupyter and start to integrate the computation and data directly into there. So yeah, that's the other piece. So I'm happy to talk more on any part of that.
I mean, this is my dream. It's like use LaTeX only when you need to do math. The rest of the time down, you know.
Yeah.
I'm still like befuddled why this is not the default, you know. It just makes so much sense.
Yeah. It's well, there's many years of work that has gone into MyST, so I think it's not easy to get everything that you need out of Markdown, and especially in sort of a user-friendly way. And again, like most of what scientific authors want is either the Word docs or the PDF docs out of that at this stage. And so that needs to be a first-class citizen in there in terms of like really good templates and ways to transform that. And so I think that's one of the things that's held it back, is that we aren't targeting HTML, and Markdown has traditionally only targeted HTML.
So export to PDF is a core function of MyST,
Yes, yeah, yeah,
and you can say
and good PDFs and sort of like really good template support as well.
okay, and so essentially you can specify a template and it'll transform and output that template.
Yeah, because it's sort of it's semantic. I don't know. I don't have a good slide to show. But all of the content is in that abstract syntax tree, and then you can transform it out to different templates very easily.
So each of the journals that you have essentially creates a template for their paper. And in the case that someone wanted to submit to many different journals, they could then just export to 4 different template styles and then submit it.
Yep.
We had
Yeah.
a system that allowed for non-competitive journal submissions.
Yeah. Yeah. Exactly. And again, like the things that matter from the scientific point of view are the fact that you have structured data, like there is an abstract and there are references like that. That's actually the information that matters. And then journals can wrap their own like branded whatever around it and PDFs around it.
Okay.
How good is the JAST you can output on the other side?
It's better than PLOS. If that's a so that's one of the folks that we're working with at the moment, and they're stuck on JATS 1.2 and just a whole bunch of challenges, especially working with some of these other
I
like
mean, this is
latex
like,
submissions as well.
yeah, well, this is doing God's work, Rowan, because like figuring out the data wrangling to output decent JATs must have been the topic of many sleepless nights for you.
Yeah. It's like it's also one of those sort of depressing things, because JATS is just a terrible format anyways. At least it's a standard, which I think is like, that's
Yeah,
actually a good thing because you can build on top of it.
yeah.
But it's not, I don't think it's what we need for the sort of open commons future that's ahead of us. Like I think some of the, yeah, there's different things that we need there.
Yeah, I mean, I agree. I think it's also a way to just make it needlessly hard to break
Yeah,
into the scientific
yeah,
publication market, and this is
yeah,
one of the modes that's used as a
yeah,
technical hurdle
yeah.
to ensure anti-competitive essentially practices, right?
Yeah,
I kind of feel this way
I don't
because
think it's
it's
I
so, yeah, it's just
well
so
yeah,
convoluted and
sorry, just
unnecessary.
delay. I don't think that the people who have been pushing those standards certainly didn't set it up um as sort of that anti-competitive or overly complicated piece. I think it's I agree that it has come that way, and so people are like, especially journals, will say, "Do you create JATs?" And like they don't even use JATs on, like if you look at Elsevier or Wiley or any of the big publishers, none of them are using JATs. Honestly, like they are all using their own custom XML stuff, and so like yeah, it's an open standard that few people are actually using. Basically
Oh, that's interesting. I
only
heard
when you
there was
get over the PubMed.
variations. So that's super interesting because I thought they were that they just had like little, a publisher level idiosyncrasy. But you're saying that it's actually no, they're just not abiding to the JAS spec. They're doing their thing.
Yeah, Elsevier and Wiley are not doing that at all, and so like those are the two big ones. But then if you like look at PLOS or eLife or some of these other sort of more modern open journals, they absolutely are. And then it's down to sort of publisher idiosyncrasies, um, and then like smaller journals are just like barely scraping by with like add an abstract tag to an XML and send it over to Crossref, and that's not JATS either.
Yeah. Yeah, no, super interesting. So like really like the focus is so the MyST community is then it's not just the markdown enrichment, it's really the ability to interoperate in a sense, right? With
Yeah.
data types, like the data wrangling step, right?
Yeah, I see that as like ways to is that sort of onboarding ramp to structured scholarly data, and that is something that is completely missing in the ecosystem. Really, is there's no ways to, as an author, just like write your stuff in a friendly way and also get this like rich scholarly metadata that has the ability to not only interface with what we have today, but also interface with what we need tomorrow. That bridge doesn't exist, and that's
I
the
mean,
thing that MyST is trying to build.
you need like for this to work, like you need MyST, but you need the authoring experience, and you need the submission experience that needs to essentially use as a submission support the MyST object. And then you need the reviewing experience, which should happen in app in a multiplayer way, where all of the people that are involved in the co-creation of the research object, they essentially do edits with track changes over both data drives and MyST objects. And then the publish stage, right? You need to have like a workflow management system, right? That goes all the way, that subsume things like Scholastica and so on and so forth, right? And then that goes all the way to the publishing experience where there's the final, editor says, okay, let's go, right? And if we manage that somehow, I think that could create like tremendous, not just like efficiency gains or like reduction in the production marginal cost of producing, but also like very very good externalities in terms of the quality of the scientific record, right? But it's a
Yeah,
huge lift. There's like
yeah,
like doing this as a single company is just not possible. Like right now we are in this phase where we're like, okay, where do we go next? So we do the MyST editor authoring thing, or do we do the the journal management kind of Scholastica thing of it? It's like start a journal, start a community. Here's workflows and systems and permissions and roles and sensors and actuators so you can do your job, right? The thing is, without the entire stack, it's almost like you fail to deliver half the value that the entire stack would deliver. And therein sits the problem. And so, finding ways like how we could build, like, I don't know, for lack of a better word, like a zaibatsu, like a collective of people that are uh, um, addressing these different things, knowing full well that, just going in ourselves, we can't do everything. It's kind of like a coordination challenge. Could be interesting. I could see a future in which, like my ideal future in a sense is like there's all this community of tool creators, right? And they come together and they deliver the full experience, right? The full stack. And they're all incentive aligned in terms of sustainability because there's some retro public good funding mechanism, right, associated with that. So every time a scientific society, generates value and generates capital, there's a retro PGF allocation, right? That is then like passed down to all the open source projects that are critical for this thing to work. And there's a lot of them if you go deep enough the thing, right? And it seems this is like from just like a structural point of view, like we need to figure out something because we can't do everything. We have to put our minds together.
yeah. No, I think like what you're saying is totally right, and then like the added complication on that is that you need to be able to deliver the full value proposition before you can start bringing certainly large societies over. Smaller societies, you can do stopgap in between bits and pieces. And then lab groups or whatever, you can also get them over the line. But yeah, it's tough. Yeah, and then there's the added complication of the coordination problem on having like multiple companies, societies, open source projects working together towards some of these things. I think that's also like a massive coordination challenge as well.
Yeah, yeah, yeah. We should think about how can we
Yeah, I
like.
don't have good yeah, I have no idea. The way we've tried to solve it is working in these external open communities that have existing governance structures around them, like the Jupyter community that can also reach a broad audience. So our goal there, like the MyST project, for example, has about 15% adoption in current Python documentation tools. And so people are already using that syntax. There's like the possibility that you can have wide adoption in a community there by joining and sort of working inside of those existing
Oh, that's
structures.
interesting. So that's like here it's part of the Python, your Python,
Yeah,
environment manager, all of these things, and then it's like a package that people just happen to use, in a very bottom up way, and they're
yeah,
like, well, how the hell can I actually publish with this? And
yeah.
then boom, right?
Yeah, so if
Yeah.
we can get the, well, I don't know, our focus is Python community, get them over the line, then people are already like familiar in writing these tools. It's all open source, it's all part of the Jupyter community, it's better integrated into Jupyter as a front end, which is adding real-time collaboration and document tracking changes. So the authoring tools again are starting to get fixed up, and that's like one part of the upstream change that needs to happen. And if you don't have that adoption, nothing else is going to actually change. With the caveat of like you also need all of the other stuff. Yeah, so
I can see
but
that.
like yeah, but like you need that first, like I like Ellie was talking right before this, is like if you're just giving a PDF document, like you can do some stuff on it, but like man, is like the combination of OCR and like reflowing and like the amount of like PhDs you need to throw at a PDF document to like read it in a structured way is like insanely hard.
Oh no, no, it's
Um,
insane. Like everything around PDFs is just absolutely insane. Just like rendering the damn thing like in an efficient way,
yeah,
just that is hard, you know?
yeah, yeah. And
Like,
then yeah. And then like next door, there's like a Chrome browser and like billions and billions of dollars that have gone into the rendering of that. And like we're just like, well, PDFs are
yeah,
great
yeah,
too.
and then you gain like a newfound respect for like this Adobe PDF editor after you fought with a PDF for some time with like the dark side of the deep innards of the PDF. You're like, this is magic. This is
Yeah,
a relic of like, a forgotten age. It's
yeah,
like browsers,
totally. Yeah.
Yeah, yeah. I
So
mean,
yeah, what's your? I'm assuming, or maybe you're one of the DeSci founders, or are
yeah, yeah.
talking.
Chris, I think we
Okay,
we uh we
okay.
met a few
I
times over
see.
Zoom as we were
I see your
chatting.
video. Yeah. Okay. Yeah, I don't know. I don't know how the like the sort of more consortium or governance mechanisms. I'm not sure how to
Yeah,
attack that
yeah,
problem.
yeah. I think that's a big thing we keep hearing also. Yeah, we have to figure out like the open source governance principles to enable scaling of coordination across open source communities and across projects. I think that's one part, and as you say, that's part of the coordination overhead. But I think it's probably like like a first step that's really important. And I don't think we should reinvent the wheel. I think we should use existing successful communities as like templates and reuse this and like, you know, have a maybe like, I don't know, like nonprofit affiliation or like, you know, you need to like set up like the frameworks and this, like the moment you try to coordinate more than 10 humans across different organizations, at some point you need like frameworks and governance, you know.
Yeah.
So that could be like a worthy thing to like for us to spend some time on. Because we haven't really been active on this, you know, we end up being like so heads deep into like coding and
Yeah.
shipping the next set of features that all of this stuff. I mean, it's same for you, same for me, you know, we kind of lose track of these things. But I think there's tremendous potential. I'm curious, like from your perspective, you know, so we're thinking of doing like a test integration of MyST in our app. Yeah, so this is we're gonna like try and do like the quick and dirty just to see how things can fit together, you know.
Yeah.
So we're also happy to like give you a demo of this as soon as it's out, and you can,
Yeah,
you know,
that would
you're
be
like the
awesome.
foremost expert on this. Like we're very
Yeah.
fortunate, you know.
Yeah. Yeah. I feel like it's like one of those things where Curvenote, and like this is one of our challenges, is like how we separate out from the open source community to be delivering sort of that, like, I don't know, proprietary or service based value on the outside of MyST, but where most of our development efforts are actually going into these open source tools. And so that's sort of a massive challenge for us as a sustainability point on our
Yeah,
company.
totally,
Um,
absolutely. And this is the nut we need to crack, right?
yeah, yeah,
And
yeah,
and and
because
and
yeah,
yeah, because like, yeah, you have to like run like kind of an overleaf model for sustainability, but then your effort goes into the OSS part, and that
yeah,
just makes life uh I mean, in this space, especially scientific publishing and scientific tools, there's like, you know, this is the right path, but it's really hard. And
yeah,
like figuring out, you know, there should be some sort of like yeah, I'm really interested in retro public good funding mechanisms personally, and like you know, there's this project called drips network, and
yeah,
it's kind of like really interesting, where they essentially hook up like open source repositories to drips of cryptocurrencies
hmm,
that essentially you are used to like fund the OSS development teams of like core infrastructure, right? And so you can have drip lists where you have, you know, you specify in your repo like what parts of your projects need the most funding, and then that goes to your open source contributors and developers. And I think that's like one of those future models of like how we can, you know, solve this challenge. Like you need like retro PGF models, right? You need a way to be able to simply transfer and channel value back to people that execute on like the big development priorities, right? Um, yeah, I'm super you know, happy to explore these things with you as well, and you know, bridge also like this world of because, you know, like crypto has a bad rep, and for
yeah,
very good reasons.
yeah,
But you know, if you look at the tail end of it, it's all about figuring out, you know, unlocking new coordination devices and new social technology as ways to like coordinate humans more efficiently. And I
yeah,
think that's a really like powerful vision, you know, and especially like the Optimism Network last year has allocated over 150 million USD to like retro public good funding.
yeah,
They're really interested. The Falcon Foundation just started a retro PGF program, the Ethereum Foundation as well, and essentially these massive crypto networks are committing, you know, a larger part of their income than any other businesses in history to like retro PGF of open source communities, right?
mm,
So this is like the bright side, you know, this is the light. And I think there's a lot of like really interesting novel coordination device mechanisms that are emerging for creating sustainability for some of the core things that we rely on. Because there's one thing in this place is that everything needs to be open source by default. There's no other possibility, you know. So that creates like a whole other new set of incentive challenges, because in a world where things don't need to be open source, you can just be like, hey, I'm proprietary, I'm not showing you my code, that's my moat, you know. And
yeah,
in that world, you can't do that. So then it opens up the question of like, you know, okay, you know, it's just like you're playing Civilization. It's like, what's your next like social tech unlock here? It's like, you know, open source funding sustainability model, you know, unlocked, right? Because if you don't unlock that, you can't progress like to the next age, you know. It's like,
Yeah. Yeah, when one of the or like the near-term challenges in funding and building this open source infrastructure and coupling it to solving open source funding mechanisms is like I feel like two or three of those things are happening at the same time, um, and like we're not transitioning like all of science over into DeSci overnight. Um, and so how do we like stage this is another question that I certainly have.
Yeah, it's like when you're not at the extreme of full adoption, when you do. I think we're talking about this a lot in terms of like a cold start problem. It's like it's a network
Yeah.
effect. So it's like how do you make it useful for someone individually to show up and be like, this is like I can add this open source contribution and not immediately feel like it's taking away from or like potentially interacting with my like negatively with my capacity to survive or live or all of these different things or publish. I think is a big one right now. It's like if everybody's at that level of publish or perish, then them publishing a preprint on a certain platform openly can sometimes lead to like do that negative reinforcement loop where they're like, oh, this is bad for me. um,
yeah, the question I guess is like, and this is also a challenge we face, Ron, is like, what's the path? Is it like we, you know, we deliver like from the full stack, like that full stack picture we were depicting earlier, which just has the promise of delivering all this value, right? How many pieces of this can you remove and say, we'll do this later before the thing you're delivering um, actually fails to deliver enough value that it gets adopted, right? So like how much, you know, cogs can you say will, you know, we'll keep for later? And the other question is, okay, so the other path to that is like, is there a eureka thing, like some sort of magic AI bullet, you know, that people could just say, oh, I go on Curvenote because I have free Claude to like write my thing, right? And just as a result of like this little kind of like here's immediate utility for me, you know, um, that it kind of like has the side effect of like start creating data on the network and building adoption, you know. So these are a little bit, you know, the kind of like extremes where we're you know, going back and forth on, right? Exploring both like these eureka pills and also exploring like what is the minimal stack that a scientific society would need to do uh, in order to like just have a better experience than what Scholastic offers, right?
Mhm. Yeah, I don't know. And I feel like that's going to be different for like every because we're like our focus and sort of like wedge in there is on the data science and reproducibility side. So like being able to like host that computational infrastructure is a big part of it. Whereas that may not be, well, that probably is not the exact same wedge that you're using to get into to these, well, to change things.
Yeah, I mean it's not a completely dissimilar wedge. So like the Venn diagram, there's quite significant overlap.
Yeah.
Um, I would say you have like more of a focused spec, right? Which says um, it's Jupyter based, right? That's the focused spec. We're like, you know, we let, you know, we say, hey, your data, your code, you know, pull in your GitHub repo with, you know, passing the URL, you
Yeah.
know, just, you know, get a PIDs for everything, for every individual digital object, upload your data, you know, it can be very, very big and we'll just make it available in an open network where different entities can participate in pinning it and distributing it. And and then yeah, so like it's like, yeah, the Venn diagram is there. And what I kind of like hope or dream for, I think there is the possibility to do this, right? It's like kind of like really nice user experience of, hey, I have my Dropbox on the right. Sorry, on the left, right? I have my Dropbox on the left, and I have my editor on the right. And now I can like build out, right, these interactive publications and link back to any artifacts that are contained in an immutable, well, not immutable, in a versionable, but that has a built-in data protection and a decentralized infrastructure behind it that lets you essentially like create that. It's almost like the Curvenote object is like the metadata over the data, right? It's like this or the mist object is like, hey, here's like, you know how readmes fulfill a role in GitHub? I think a lot of scientific publishing right now is just going to go down in flames because of AI in a sense, right? So like we can
It's going to
already
take
see like
decades. It's like they
well,
still haven't adopted the internet,
yeah.
so
Don't
I feel like
underestimate. But like, look at the sheer level of I mean, okay, I mean, it's kind of there's if you just type, as an AI language model, you go on Google or
yeah,
like anywhere, or even like Elsevier Journal, like front page of
yeah,
like the
yeah,
first sentence, I mean, it's not pretty to see, right? But what it just says is that ultimately all of these things, they diminish the value of the version of record, right,
yeah,
as the textual artifact, as the central part of science. And as you move into a world where there's more AI agents and AI assisted research, having access to the raw data and having access to the code and all of that is going to be just like a tremendous source of creativity. We'll be able to like regenerate these essentially readmes, right, glorified readmes, in an incredibly rich way for different types of audiences, for different types of disciplines, using different types of language. And it's going to be like, I mean, there's some profound, I think, profound opportunities down the road there uh, that could happen, and like, and really understanding, I think, what's the North Star in terms of like the full experience, right? Like the full thing, the full alternative, and just keeping in mind that we want to make things as machine actionable as possible because that will bring us to a better future. I think it's super important.
yeah. Yeah, I agree.
Where are you based,
Cool.
by the way?
In Canada. Yeah. Yeah.
Nice. I think we are over time. We can keep talking if we want to, though, because it keeps going. But I just definitely wanted to say, like, super thank you for coming in. I think there's like a lot of synergy between the projects and just like similar space, similar vibe. It's kind of like, well, there's yeah, rebuilding a whole, it's not just a whole tech stack, it's like a process. And so it's definitely a socio-technical system in that way, where it's you're not just changing the tech, but you're changing the people. And I think that's the hardest part for sure.
Yeah,
Yeah,
could
Rowan,
not
thanks.
could not
Thank
agree
you so
more.
much.
Yeah, no, it's fun. It was fun to talk. I feel like having other people like attack this existential crises that I feel, it's like helpful to see at least, because it's like this massive problem, and like it's not, well, I feel like there are these pockets of people working on it in next generation ways, but I'm not seeing that in en masse.
Mm.
And it,
Yeah,
like it
I
feels
was,
like
I had like the same reaction to you the other day when I was getting an email from someone who found like a typo in one of the articles I wrote. And I was like, I'm so happy you reached out because that means you care.
yeah,
And then I had this existential realization: is like, why do so few people care? Like, why do I feel gratitude over this? The guy having the most pointed, like nerdy remark, that I have to, and I'm like, I'm not annoyed. I'm super happy, because people care, but there's just not enough of you. And I felt like a kind of a sense of isolation of like, what makes this problem, which is obviously a massive problem because we're talking of the engine of progress of humanity, you know, and we're, it seems it just lacks this like inherent self-reflectivity to improve its on the own system, right? The system, like things like peer review would not pass peer review today, right? There's like all of these deep paradox embedded in that system, and it's such a fundamental engine and coordination device in humanity, you know. Why is there not people just, you know, why is it not bigger community? I understand that the market is very hard, right? So it's not a place where, it's not like you're doing a payment processor and taking and being a basis point vampire. You know, that's not how it works. Like you can't. It's a very hard space to break in, and it's very hard to get financial sustainability in these space. So that's one thing. But then it seems that even if you, it's still it's, is it a communication problem, right? Is it the fact that the problem is not known to be it hasn't been communicated properly? Like, how do we get more people in general like us who care really deeply about this? What's the pill? You know, how do we serve it? Because it is a really, like, we need more people into that space, because the rate of innovation is just going to be a function of like the, you know, the amount of people and the amount of capital you throw at the problem.
Yeah, I don't think that there's a recognition of a lack of recognition of the problem. I feel like as any time of these, like that Elsevier article that you commented on, or the rat picture or whatever, like there's just enragement in like anytime it comes up. So I think there's like wide visibility on the problem. I think that there's very limited funding mechanisms to build sustainable companies, and very, very hard to get into production workflows in science. And then as soon as you do come into that production workflow, you've actually became status quo by the time you get there. And so I don't know, like I think, well, maybe, well, it's these sorts of conversations that are like, it's the people who are like refusing to go towards status quo completely, but also figuring out how to like integrate with the current system enough to influence its direction.
Yeah,
And
it's just, yeah, we're just like playing the game of entrepreneurs on like extra hard mode, you know. It's
yeah,
like
yeah,
new game
yeah,
plus plus.
yeah, 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 yeah.
But
I
anyway,
agree with
Rowan,
that.
thank you so much. We're really happy to have people like you that care and spend the time to come and talk with us on the seminar. We love what we're doing. We'll stay in touch and
Yeah, no,
build
yeah,
these
totally.
bridges, build those coordination devices, and one day, you know, deliver on that. You know,
Yeah, that sounds
super.
great.
Yeah,
Yeah, and as you get into the MyST stack as well, feel free to reach out. We're in Discord as well. So hopefully we'll see you over in
will
various
do.
places.
Thank you so much. Have a
Awesome.
great
Yeah,
day.
it's nice to chat again.
You.
Bye
Thank
bye.
you.